So basically to write smart contracts in Ethereum, that is Ethereum is implementation of blockchain. So we use this Remix IDE. It is a great IDE. So this is the promotion page, and here Remix Online ID, you need to click here. This is a desktop app also, but most people prefer probably online IDE. And there is an
Is
extension,
there a
and
valid reason behind that, that why you use only online?
because there are many plugins you need to install and stuff like that. Because it is online, I can access anywhere if it's connected to my GitHub account, like that, or I can directly
Okay.
save it from GitHub and like that.
So
And
you
it
can,
uses virtual software as service, so the processing happens on their hand, not on the my machine. If I'm using app, it would happen on my hand, right? So we are preferring
so
online
you,
IDE.
yeah, you can save
Yes.
your time, and you can also save processing power
Hmm.
and
Yes.
the time which it takes generally to load
Hmm.
and the stuff like that, right?
Hmm. Yes, exactly. So this is the front page of Linux. Here you have some, this is a folder structure, this is search, this is a compile, and this is the deployment and run stuff. Then this is some plugin extension, and there is settings. So basically you can move between these stuff. We will see that later. And there are workspace. This is the default workspace. You can create your own workspace from here also, right? And you can connect GitHub and download and stuff like that. So yes, so and this is the console. You're basically, if you run a transaction, it will appear here. If you are printing something to console, basically it also all those things will appear here, right? So firstly, they have like some basic, some examples, like you can see these contracts, scripts, tests, apps, readme, and like that. So this contracts part is main. We are going to write our code in this. So they have given this some examples, these three examples of smart contracts, where they are storing some integer and assigning this integer, and you can see, and then there is a owner, like assigning the owner address, and then if the owner gets changed, they have written the code for that. And then there is a this third example, right? So this is the first example, right? So this thing, this license thing, you have to write on your code. This is mandatory. And this is the specification of version, like what version will this code is able to run in, and then the code goes on. So these two lines, if you were to write a new, for example, let's create one new file, let's say xmas.solidity. So extension is .sol, and you can start your file name with, sorry, with capital letters only. Sorry. Yes. So as I said, first two lines, that these lines, it is going to be the same, right? And then you are going to write a contract, that is a smart contract maybe, and that goes like Xmas, and your code, all code goes here. So once you write the code, for example, they have written this code, and they have written one
By the
variable,
way,
right? Yes.
today is Christmas, so Merry
Yes. So
Christmas to everyone.
yes, Merry Christmas. Bye bye. So the storage file they have given. Let's so you go to this compiler, you compile it. So once you see this green tick, it is compiled. If you see this running, so it is compiling. You will learn across that. And as it is compiled, now let's run it. Firstly, we need to deploy it. So there are some terminologies here. There is a account, like you have this addresses, this address, and so this is your identity in blockchain, and this is your balance for deploying and making transaction in blockchain, and this is a gas limit. And if you want to purchase something, there is a value, and uh, different, these are currencies like ether, they, right? So, and this is the contract we are going to run. So firstly, if you deploy it, it will show some information here. Status, transaction hash, from to, gas, amount of gas used, and transaction of gas, execution cost, and stuff like that is shown. So if you have any logs written, it would be printed over here. So once it is deployed, you can see transaction recorded here. You can record the transaction too, and then below that is deployed contracts. So we just deployed this file, right? So you can press this and this. So you can see we have created in this, there are this integer. So you can store this integer, and once you store this, you can, they have basically written a function to retrieve the integer that you have stored. For example, let's say 2, and if you write store, and if you write retrieve, it will just display 2, that this particular integer is having value 2. Okay, so since we don't have any like real life transaction going on, so we aren't using this value field, and this balance is also not uh, you can say making sense any here. So if you see more information in this, you can see decoded output is it is basically in JSON format. Just this value is 2, and when you have inputted here, and when you click store, decoded input would be this, right? So we are going to make one smart contract, that is hotel booking. So hotel, first letter is capital, hotel room booking rather, and dot solidity, right? So as you know, first two lines, those two lines, the version and the license stuff, it is going to be same. So let's just do this, right? And from here we are starting to write our contract and hotel room. There are a couple of things we are going to need. Probably would be function, and if you are booking the room, and so you are paying someone, right? So there will be a owner of the hotel you will be paying to, and there will be payment status, not payment status, but you can say room availability status, that room is occupied or vacant, right? And the amount you are paying, the amount status, or you can say balance is less than or equal to the actual price or not. So some test cases will be needing. So firstly, let's define our owner. So this address, uh, we will write address public owner. So this address is like this. Wait, let me show you. Address is something like this, like this. Is it visible?
Yeah, it's a kind of wallet address, right?
Yes, the owner is fixed. That is why we are making it as address. So you can consider this as a data type. That address, the transaction are going on based on this particular uh, person, or based on this particular address. So you can, instead of owner, you can identify the owner by address, the code itself. Also,
I'm a little bit confused about the syntax that you have written. It
it's
it
fine.
it shouldn't be like public address owner.
No. This is little bit different. In Solidity, it is little bit different. So you can, the website is, so they have documentation. You can go through it. Like, they are defining all this stuff like this only. Right. So
So it's a syntax base, right? It is there is no
yes,
such error. It's a
yes.
syntax that
Also,
Solidity requires.
yes. Also, you can see it is a statically typed language. This, I think in the last video I have told, this statically
Yeah,
typed
yeah.
language, and an object oriented. We also discussed this in the last one, and I was going to say this. It works on the EVM. It's in virtual machine.
Ethereum. Okay, okay, good.
Okay, clear.
Pretty much.
Okay. So this address I was saying. So the syntax might be weird, but it is what it is. Address, then public, that showing that you can use this outside of the blockchain too, right? So then after defining the owner, we would need, let's just create function of book, function, booking, and then you write public. It is a bit uh, weird, but you can get used to it. Okay,
Yeah.
and then, so Solidity provides one function required. We'll see this a bit later, but first let us have the status, whether the room is occupied or not. So there is an enum we can define as status, and we can have vacant or occupied, right? So how this status will work is, this would be considered as, if it is a 0, it would be vacant, and if it is a 1, then occupied. Maybe you can have a third one. If it is a 2, then maybe third value would be assigned to it, and status would be, can use it like this. So you would need to change the value of current status uh, when, whether in your code logically, whether the uh, room is occupied or not, and then we will need a constructor which will help owner get the transaction from uh, transaction from whoever is booking the room. So this message dot sender, this message is a global variable in the Solidity, right? It is by default. So, and dot sender, it will make basically owner will be able to receive the payment that the sender is sending. Yes. So we would need to apply something over here too. We'll do that too. We'll do that later. Right. So this constructor will be called only once. So in all the transaction, or for the whole for the whole session, owner will be only able to receive the transaction or amount for only one time, right? And another thing, let's keep the status as vacant by default. We have some status of rooms. And default status, and is a function. Right. So if this function is called, the current status probably would should be changed to occupied, right? So somewhere here there should be uh, this piece of code. Occupied, correct? And uh, wait a minute. And the value that the user will get, like the payment that user is going to take, give to the owner, will be also used by this message, this global variable message, but instead of sender we are using value parameter. So owner dot call. So you can also use transfer, then value message dot value. You can also use transfer. So basically, whatever amount that is paid by the customer would be transferred to the owner. Okay. Hmm. Now, if the status, now there is some we need more logic to uh, some of the test cases are missing. So somewhere here, if the room does not get booked twice, so we would need vacant here. So this is required, yes. So this is required had two parameters, one here and there is this message here. So if this condition is true, it will execute all these code of line after it, and if it is false, it will not execute these lines. And if it is here, if it is true, it will execute this line. If it is false, it does not execute these two lines. It will stop execution from here if it is false in general. So what we want is basically is if our current status is vacant, we would write currently occupied. And yes, so instead of making this code, this main logic code bit messy, we are using modifiers. So let's use modifier named as vacant function. It will check, again check status for if it is occupied or not. So let's move this code here. Cool. Okay. So I think we do not need to write this here and this. So this is for return. It will it confirms that this ended and it will return whatever here is to this main function. So as we have written the modifier, we need to give it to the function. So for that, we need to write it here. For example, you have two modifiers. So let's say modifier number two. So you can write modifier number two here. You have defined your modifier here. maybe. So yes, so there is one small thing, that is a payable. It is a keyword in Solidity. So what it does is it allows a variable or maybe a transaction to receive the payment or any value. For example, this message dot value, it will allow it to transact to functions or constructor maybe. Okay, so you just write the keyword here, payable. So owner will be able to receive or send ether or maybe any other currency, but it will be able to receive anything. And we want our function for payable too, because we have message dot value here, right? And let's see where else we need to write this in the future. Okay, so this method was older, so there is a new method. Is we use a call function for transferring the data or amount of ether user has paid to the owner. So you write like this: value message dot value, and uh, empty string. You can write anything here, but let's keep it empty and store this maybe in. So receive amount of bytes used and uh, what amount has been used. You would need to store this. Let's store this in boolean, and I could not understand this term memory, but let's we are writing this. Yes. So this and this the improved version. Instead of transfer method, we are using call method. Okay. Mm, yes. So
I I think the older one was like easy, or you can say not much complex, but this newer version is
yes,
pretty much complex
yes,
to understand at first.
yes. It is generally reversed because in the past days the functions are like this and now they are like this, but here it is now this because I don't know. It is complex. Yes, you are right. So
Much complex, but it may provide more improvement or more
yes,
security,
probably,
I
obviously,
guess,
yes. Hmm.
because it is
So
said that it is improved.
yes, so we are done with status stuff. We have checked the status and we have given the condition if the status is occupied or not. So the next thing we need to do is whether the person transacting, for example, you are in Amazon, right? And you have 10 rupees in your balance, and the thing you want to buy is of 100 rupees. So Amazon doesn't allow you to buy that, right? Because you don't have enough balance. So instead of writing the balance logic here, let's create a modifier outside of the function, which is an integer. So it is a tradition to write local variables like this. This is a local variable. So you would start with underscore, basically. So this code will check balance, and it will use message dot value. Firstly, it will use require because we are checking if the message dot value or the balance is greater than or this amount that we will define on the function side when we are here. We'll define it here. But let's write a variable here. So one of the good thing about this modifiers is you can reuse this code in any other function too, right? So that is a good thing. You can use this here also, and maybe in next function if your code is like that, you can use this also. And the message would be not enough balance. Right? And we need to add it to function. So we write cost, and with it we need to write, for example, a room costs 2 ether. Minimum balance needed is 2 ether. So this amount is 2. So you can write 2 here, but it would be static. So let's just write this here. Right. Okay. Anything else remaining? Let's just compile it. So yes, it is
Before
showing some
before
error.
you
Yes,
before you compile, can you
yes.
explain thoroughly that what are the steps that you have taken?
So
Can you
yes.
repeat?
Mhm. So what was the first thing we have done? Can you remember?
Yeah, we have said that these are some of the things like the room status and the owner address that we will require for a hotel room booking scenario. And then
Hmm.
you have started making address to owner. You
Yes.
have
First
write
thing we did
address.
was this, right?
Yeah,
Let's create an owner. That was the first thing. And then
yeah,
owner would be receiving some payments, right? So
yeah,
from the sender. So uh, it should through the transaction it should receive the amount only once. So as you know, constructor only executes once. So we have written order is equal to message.sender, so it will receive once only. And then status of rooms, so we have used enum for that. Enum status vacant and occupied. So vacant would be in logic, it would be used by 0. We will see once we deploy, you can see the value of status, current status. If it is 0, it will be vacant. If it is occupied, it will be 1. So,
yeah.
and we
Got
have defined a current
it.
status based on this, and by default, we want our current status to be vacant. So in the constructor, we have written status dot vacant.
Yeah, yeah. Then you have made modifiers to check for
Then
logic.
function, nah. Then we have made function booking, then public, and then
Yeah,
we have done. Yeah, yes. If customer clicks on book, so the room would be occupied, right? So we have written current status equal to occupied. But instead of writing all other logics in the, so yes, one thing we are
same
missing here
function.
is this. All the logic in function we can use modifier, so we can reuse them again. So two modifiers we have used is backend function and cost for checking the status, or and it gives message also, and whether the booking person or the customer has valid balance to book a room or not. And then you have seen that how value or uh, ether is transferred here, this line of code. Firstly we have done this, but this was the improved version, right? Yes.
Yeah, you can run.
Okay, so it is showing some error, expected identifier but got payable on the line number 14. Okay, where I think will be, let's compile it. And there is again one error. Type address is not implicitly converted to square on the 18th line. The 18th line. Okay, so this would also need some transaction. So we are writing payable here too. So every lines that are executing, like they are having connection with transaction stuff, we are writing payable there. Let's compile this. So it is successfully compiled. As you can see, there is no errors. There are two warnings right here. Mm, yes. So after the compilation is done, you can deploy it. Right. Let's deploy it. So it has been deployed. There are two sort of uh, main features of the code that are displayed here. One is booking and the owner, this owner. Right. So if you click here, it would not allow you to do so because not enough balance. We haven't provided anything like we have this much balance and like that. So let's change our account. So if you change this account, right, your address would be this, right? So you are associated with this address. No other owner can get the uh, balance from or get paid from another customer. So this is fixed. All the customers knows or internally that this is the address I want to uh, pay to, right? So this way security is implemented. You can see the security aspect of this code, and this value we will use, and we change the currency to ether. And let's do, we for example we have 2 ether. Let's deploy, right? Hmm, let's write 2. Why is it not working? So the owner is same. Now if you book it, you can see the code is executed and the transaction is successfully executed, and there is some stuff you can see. Yes. So it would show the status here. So if you have 0, let's say you have 1 ether, you have 1 ether and you try to book, so it will show currently occupied. So it is, yeah, as you can see, it is currently occupied here. If you change the owner, just click here. So you cannot change the owner because, right, it is fixed, it is bind to uh, this address. You can use different accounts. Let's use this account, and let's say you have 2 ethers to spend on. So if you book it, uh, yes, you need to write 2, but keyboard is booking. Okay, so as you know that it is currently occupied, right? We have booked the room once in the code. We currently haven't implemented a feature that allows you to cancel an occupied room. So that's why it is not showing. What we can instead do is redeploy the whole code, and then, for example, let's say we have 2 ether and we are using this address as customer. Let's say 2 ether, your owner is this, and let's book the room. So after even deploying, it is not sort of doing the, yes, now it should work because the owner is also different, and I think it just recreated the whole thing. Yes. So the room has been booked. So if you try to book the room now with 0 ether, it will show not enough balance, plus it is currently occupied, right? It is currently occupied as we have booked it. So let's we need to check that too. It should show not enough balance. Let's try to buy a room with 1 ether. So this is the owner. Try to book. It will show not enough balance.
Yeah, got it.
Yes. So this is it. We can maybe implement one more feature here that you can probably guess. You can cancel the booking, and other people can book the room like that. Yes.
Yeah,
So
so
this was the smart contract we have written today in Linux. online IDE. Yes,
So
any
yeah,
question?
no, it was very good hands-on that you have given us on
Yes.
Solidity on in Remix ID, and
Mhm.
probably you can deploy this code on GitHub or somewhere else,
Yes.
and
Hmm.